There are three components of troponin. One will be binding with the calcium, one will be binding with the tropomyosin, and one will bind with the actin. The actin binding troponin is permanently bound with the actin, while the calcium binding and tropomyosin binding troponin bind only in case of contraction. So when calcium ions are released from the sarcoplasmic reticulum, they will be straightforward going towards this troponin molecule, and they will bind with the calcium binding component of troponin. When they will bind with the calcium binding troponin, the troponin which will bind with the tropomyosin will be activated. So when calcium will bind with the troponin, troponin will bind with tropomyosin. And when troponin binds with tropomyosin, what will happen? The calcium binding sites of actin protein, as you can see this black thread, it will be displaced from the regions which will bind with these myosin heads. These are the cross bridges or the heads, globular heads of myosin molecule. As you can see, they are also bound by the ATP. ATP will bind with these globular heads, and these globular heads are actually ATPase enzymes because they break ATP, and the energy released from these ATP will be used for relaxation of muscles after contraction. So calcium bound with the troponin, troponin bound with tropomyosin, and when troponin bound with the tropomyosin bound with troponin, the tropomyosin which was covering actin will be displaced, and the actin beads will be exposed. So these exposed actin globules will bind with myosin heads. When they will bind with these myosin heads, what will happen? The myosin heads will pull these actin filaments over them. So what will happen? When they are being pulled from both sides, they will shorten this region which is called as A band. I band will shorten. So what will happen? I bands will shorten, and ultimately it disappears, and the whole region becomes the A band. This whole region will become the A band. So this is the mechanism by which muscles contract.